Hey, I was thinking maybe if I get enough views and enough hype around my graph videos here, we could get this thing to go viral and I could start my own Trig Graph YouTube channel. Anyway, all right, let's look at how to graph a tangent or cotangent, in this case a tangent, with multiple transformations. So I'm going to walk you through the steps that I would use if I were going to graph this function here from class. So the first thing that I'm going to do is I'm going to notice this vertical reflection, and I'm going to make a little note for myself, hey, don't forget to reflect, because normally my tangent graph is going to look like this, right, where it's increasing, but now I'm going to reflect it, so I know when I'm done, my tangent graph should look like that. It should be decreasing. Then next, I notice that 3, which means I have an amplitude of 3. And when we talk about tangent and cotangent graphs, that is our focus for when sine and cosine are equal to one another. Right? Normally that happens and we get a tangent or cotangent of 1 or -1. In this case, because we're multiplying by 3, then in those situations we're either going to have a 3 or a -3. All right. Now I notice that I'm not shifting up or down, even though we don't really call it a sinusoidal axis, but just noticing here that I don't have any vertical transformation shifting up or down. So I'm going to just stick with my x-axis that's given. Now let's talk about the period and the phase shift. These are our horizontal transformations, which is going to require me to do some work here. I want to factor out this pi over 4 from my theta so that I can isolate the horizontal stretch or shrink from the horizontal or phase shift. So first of all, I divide that by pi over 4. Now, when it comes to the phase shift, I have to think of that pi being divided by pi over 4. So if I'm doing pi divided by pi over 4, that's the same as pi times 4 over pi, which is going to give me 4. So this would be theta minus 4 units. All right. Now, when I look at this, I realize, okay, my phase shift is going to be to the right 4 units. And then I also notice that I've affected the period. What is my new period? Well, I start with a typical period of tangent, which is pi. Now I'm going to divide by that b value, which is pi over 4. And just like I did when I factored it out, pi divided by pi over 4 is equal to pi times 4 over pi, which is 4. So I have a shift to the right 4 units, and I also have a period that is 4. Now, that means that I could start at 4, right? If I'm shifting to the right 4, that could become my 0. But it also means when I'm shifting the equivalent of my period, then really my graph is going to look the same as if I didn't do a shift at all. But we'll get there. So for me, I might not recognize that, so I'm just going to start at 4, which means if my period is 4 units, my first period is going to go from, well, I would consider 4 to be my 0. And now let's talk about that before I start filling things in. So normally when we are making our marks, we would have our first quadrant mark when sine and cosine are the same, and then we would have when cosine is 0, we get an asymptote, and then when I back up, I have sine and cosine being the same, and then I have my asymptote when cosine is 0. So let's talk about when those things are going to take place. Well, my entire period for tangent is between those two vertical asymptotes. So that means in this case that I'm going to have that period is a total of 4 units, which means I'm going 2 units away from the middle of my period in the right direction and 2 units in the left direction. That also means that this is going to be a 5 and this is going to be a 6. So if I consider 4 as being my typical 0, because I've shifted to the right 4, then that would be when sine is 0, so my tangent is 0. Now as I move forward, sorry, this should be a 3. Now as I move forward into the first quadrant, that's when tangent and cotangent, when sine and cosine are equal and tangent or cotangent becomes 1. So typically, as I move through the first quadrant, I would have a 1 here. In this case, it would become a 3. Oh, but I need to reflect, so now I'm moving down here. And then as I approach the end of the first quadrant, that's typically my pi over 2. When cosine is 0, I get my asymptote, so I have something that looks like this. If I go backwards, I get that going back, normally I would have my tangent being negative, but now it's reflected, so it's positive, and then I back up to my asymptote. So now you can see that I treated 0 being transformed to, or shifted over to the right 4, and now I've graphed my typical tangent period based on that. If I want to do another period, I'm going to go from an asymptote at 6 to an asymptote at 10. Halfway between is my 8. I've got 7 and 9. And I've got my 3 points, my 0, and then my time when sine and cosine are equal. So that's 2 sample periods. Again, you could also have started with 0, and you would have a period that goes from 0, 1 to 2, and then back to -1, and another asymptote at -2, and that's fine as well. So I hope this helps. Again, that would be my approach on this problem. You may take a different approach, and you may graph different periods, but your tick marks should be the same. Your details should be the same. Keep practicing. I promise we'll get there together. Cheers.